An aircraft is flying at an indicated altitude. An aircraft is flying at an indicated altitude of 25,000 feet. 25,000 feet. Static air temperature is minus 50 degrees Celsius. Static air temperature is minus 50 degrees Celsius. Find A, true altitude, B, density altitude. So first let's find out true altitude. So to find true altitude from indicator altitude, you have to find alticore, and alticore is equal to 4 feet per 1000 feet per ISA deviation. Right, so you have to first find out ISA deviation here, which is
actual
T actual
minus 35
T ISA. Right, so T actual is the static air temperature. You have to now find out T ISA here. How do you find T ISA?
T ISA is minus 35.
So 15 degrees Celsius minus a lapse rate of 2 into 25,000.
35,000.
So for every 1,000 feet, it's going to be 2 into 25. So 15 minus 50. How much is that?
Minus 35.
Minus 35. Sign is very, very important. Minus 35. Now you have to physically understand the physical meaning of this minus 35 TISA. So you see that temperature ISA is minus 35. Actual temperature is minus 50. So what can you say here? The actual atmosphere is 25 degrees Celsius colder than the expected ISA temperature. And that is what we represent by defining this term ISA deviation, which is T actual minus T ISA. T actual is minus 50. So be very careful here. We have a minus, and this T ISA also has a minus. Yes, minus of minus 35. So how much is it? Minus 50 plus 35.
Minus 15. Minus 15.
You see here, minus indicates colder and 15 indicates that it is 15. The actual atmosphere is 15 degrees Celsius colder than ISA, and hence you will have an error. Alright, so let's find out what the alticore is.
Alticore says that is 4 feet per 1,000 feet of indicated altitude.
Very good. Per 1,000 feet of indicated altitude, which is 25,000. Therefore, it's 25.
25 into ISA deviation is 15.
15. You can even take this sign, that's fine. It will come out with the sign. The 25 into 4 is 100, into 15 is
1500.
1500 feet. Right? Now if I put this minus sign for 15 and that gets carried forward, which means I have to apply alticore to indicate altitude straight. So its indicator altitude is 25,000 minus 59.
Minus 15.
Sorry, true altitude is indicator altitude minus 15,000 feet. That is 25,000 minus 15,000.
23,500 feet.
23,500 feet. Now you can see here that the aircraft is expecting a warmer temperature, but the actual temperature is colder. So the aircraft is expecting a warmer temperature, but the aircraft ends up in a colder air column. Therefore, what happens here is that the altimeter is going to read high, H, which means the indicated altitude is more than true altitude, and that is what is called as being overread.
Overreading.
Right? So you can see that indicator is more than true. You can see that true is actually 23,500, indicator is 25,000, so it's overreading by an amount equal to alticore, which is 1,500 feet. Right? That's it. Now let's look at density altitude.
Density altitude is pressure altitude plus 120 times of 118 times of ISA deviation.
118 or 120 times of ISA deviation. Yes. So what's the pressure altitude?
It's 25,000.
So we believe that in this case it is what is given in the question, pressure altitude. Yes, that is 25,000 plus 118 times ISA deviation is.
ISA deviation is minus 15.
Again, take care of the symbol here, the sign here, minus 15. So how much is that?
25,000 plus minus 250 23230 feet.
This has to be the pressure altitude. Huh? So we assume that what is given in the question is pressure. There's no other way we can find pressure altitude. So we have to assume indicator altitude as pressure altitude. 23,230 feet. Let's try doing it using the CX3 and the equation. So you can probably go with the CX3 as far as your exam is concerned, but there are two different methods still, right? An aircraft is flying at a pressure altitude of 17,000. Pressure altitude of 17,000. With an ambient temperature of minus 30 degrees Celsius. Ambient temperature is minus 30 degrees Celsius. 30. Find
Yes.
true altitude and density altitude. So ambient temperature is nothing but the temperature of the immediate surrounding.
Is the outside air temperature and static air temperature same?
That's right. Immediate surrounding. So basically, it's the outside temperature immediately surrounding the this particular pressure altitude, 70,000 feet. There are different types of temperature. Surface temperature, you have ambient temperature, we have absolute temperature. So different types of temperatures involved. You will learn that in the chapter called temperature back in Met again, right? Yes. So what is surface temperature? Have you gone through temperature chapter? No, you haven't. Okay, forget it. All right. So you can find. Yeah, let's find out true altitude.
So like this pressure altitude is the same as my indicated altitude.
That's right. It is what the pilot sees in his cockpit instrument altimeter when the altimeter Coulson window is set to 1013.25 Pascal. Right. So true altitude. To find true altitude from indicator altitude, you have to find altimeter correction, which is 4 feet
per 1,000 feet of indicated times of ISA deviation.
1,000 feet of indicator altitude per ISA deviation. Correct. So you have to first find out ISA deviation here.
Yeah. So first we'll also go through ISA temperature. So ISA temperature at 17. This is 15 degrees minus 2 times of 17.
That's right. TISA is 15 degrees Celsius minus 2 times 2 degrees Celsius per 1,000 feet. That is 17,000 feet. Therefore, the 17,000 divided by 1,000, that is 17. The 15 minus 34, which is
minus 19 degrees centigrade.
minus 9 degrees Celsius. You can see here.
So
The ambient temperature is minus 30. The ISA temperature is minus 90. The aircraft expects a temperature of minus 90 and experiences a temperature which is colder.
okay.
Right? Colder by almost 11 degrees Celsius.
Yeah.
Correct? So that is what is indicated by ISA deviation. So ISA deviation is always T actual.
ISA actual minus ISA.
ISA.
Yeah. So
Minus of minus 90.
Yeah. So actual is minus 30, minus of minus 90.
Which is minus 11 degrees Celsius.
Yeah. Minus 11 degrees centigrade.
So the meaning of this is the actual atmosphere is 11 degrees Celsius colder than ISA. Right? So if you think about it, the aircraft is expecting a warmer atmosphere. It ends up in a colder atmosphere, colder by 11 degrees Celsius. Therefore, the aircraft instrument is going to overread, which means your indicator is actually more than true.
Higher than true
Right.
altitude.
By how much is what the Alticon is going to tell us, right?
Yeah.
So let's find the Alticon value here.
The altitude value is
4 feet.
4 feet multiplied by 1,000, like 17,000, 70 multiplied by.
That's right.
ISA
1,000
deviation,
feet
that
of
is minus
indicator altitude, which is 1,000 feet times 17,000 feet. That is divided by 1,000 is 70 multiplied by it's per degree Celsius of ISA deviation. Therefore, it is 11 degrees Celsius.
Yeah.
Right? You can carry the negative sign if you want. That's still fine. So 11 into 17 into 40.
Yeah, 748.
748 feet. Right? Now if I carry the sign, it's going to be minus 748.
Yeah.
Right? Therefore, alticord is always applied to indicate altitude, which means true altitude is equal to indicate altitude minus 748.
Minus 748 equals to true altitude.
That's right, 17,000
True altitude
minus 748, which is
16,252 feet.
16,252 feet. Now, if you look at this here, you can see that since the aircraft instrument is overreading, your indicator has to be more than true. You can see that true is only 16,252, indicator is 17,000. This is a dangerous situation because the aircraft is telling you that you're higher than your actual altitude because it's overreading. Right? Yes. So let's find out density altitude using equation.
Yeah, so density altitude, we know that it is equals to pressure altitude plus 118 times ISA deviation.
Yeah, ISA deviation.
Yeah, so pressure altitude is 17,000 plus 118 times ISA deviation in minus 11.
Minus 11. So be sure that you carry the sign with you, minus 11. Yes.
It's 15,702.
15,702 feet. Let's find out using the CX3 now.
Yeah.
15,619.
15,619.
So see, there can be a difference between your CX3 and the calculated value.